On a calm morning in early autumn, the canal looked almost perfectly still. The water flowed slowly between brick embankments stained dark by years of rain and algae. A few ducks drifted lazily near the reeds, dipping their heads beneath the surface in search of food. A cyclist rolled across the narrow bridge overhead, tires whispering against the pavement. To anyone passing by, the canal seemed peaceful, just another quiet corner of a European city. But beneath the cloudy green water, something else was moving. Hidden between stones, inside muddy tunnels carved into the banks, and crawling silently along the canal floor, thousands of small creatures were at work. Their legs clicked faintly against gravel. Their claws scraped through silt. And slowly, almost invisibly, they were reshaping the river. These were Chinese mitten crabs. Scientists knew them by their formal name, Ariakir sinensis. To fishermen and engineers along Europe's rivers, they were something else entirely, a growing problem. The crabs had arrived quietly, traveling farther than any of their ancestors had ever moved in the wild. Now they lived in places their species had never seen before, beneath steel bridges, inside drainage pipes, and along riverbanks lined with concrete instead of reeds. And once they arrived, they were remarkably difficult to remove. Across Europe, from the canals of the Netherlands to the tidal waters of the River Thames, the mitten crab had become one of the most successful aquatic invaders on the continent. Small, adaptable, and endlessly persistent, it behaved as if every river it entered already belonged to it. A crab with woolen claws. At first glance, the creature did not look particularly threatening. An adult mitten crab was roughly the size of a human hand. Its shell was brownish-green, slightly rounded, with legs that stretched outward like delicate mechanical arms. But what made the species instantly recognizable were its claws. Each claw was coated in thick brown hairs, dense bristles that formed a fuzzy covering over the pincers. When the crab lifted its claws, the effect was unmistakable. They looked like a pair of tiny wool gloves. That odd feature gave the species its common name, the Chinese mitten crab. In its native home along the coasts of East Asia, the crab had been known for centuries. It lived in rivers and estuaries near the Yellow Sea, especially around the broad wetlands and tidal channels of eastern China. The animal's life followed a remarkable journey. Young crabs hatched in brackish coastal waters. After growing strong enough to survive on their own, they began a long migration upstream into freshwater rivers. There they would spend most of their lives feeding, growing, and exploring river systems that sometimes stretched hundreds of kilometers inland. Then, when they reached adulthood, an instinct older than any human harbor called them back. They turned around. Every mature crab began a long downstream march toward the sea, traveling through rivers, canals, and estuaries until they reached salty coastal water where they could reproduce. Scientists called this life cycle catadromus, a pattern shared by only a few aquatic species. For the crab, it was the key to survival. And, eventually, to global expansion. Stowaways of the shipping age. No one could say exactly when the first mitten crab arrived in Europe. But by the early 20th century, something unusual had begun appearing in rivers far from East Asia. The earliest confirmed record came from Germany in 1912. Fishermen pulling up their nets along the River Aller found strange crabs with hairy claws tangled among their catch. At the time, the discovery seemed like a curiosity. Few people realized they were witnessing the beginning of an ecological story that would unfold across an entire continent. The explanation, scientists later concluded, lay in the massive expansion of global shipping during the late 19th and early 20th centuries. Cargo vessels traveling between continents carried more than just goods. Deep inside their hulls, they stored enormous tanks of seawater called ballast water. Ships used ballast water to stabilize themselves during long voyages. When they unloaded cargo in one port, they pumped seawater into these tanks to maintain balance. Later, when they arrived in another port to load new cargo, they released the water back into the sea. Along with that water came countless microscopic passengers. Larvae, tiny crustaceans, algae, plankton, entire miniature ecosystems moved silently across oceans inside ballast tanks. Among them were the drifting larvae of the Chinese mitten crab. When the water was released into European ports, the larvae suddenly found themselves in unfamiliar rivers and estuaries. Many died. But a few survived. And that was enough. Over time, more crabs arrived through other routes as well. Some were transported deliberately for food markets, since mitten crab was considered a delicacy in parts of Asia. Others escaped from aquariums or were accidentally released during trade. Once even a small breeding population established itself in a river system, the species spread rapidly. European waterways were perfect highways. Canals connected rivers that had once been isolated. Locks and shipping routes allowed aquatic animals to move freely between basins. When obstacles such as dams blocked their path, mitten crabs often simply climbed out of the water and walked across land. Yes, walked. On damp nights, hundreds of crabs could sometimes be seen marching across riverbanks, fields, and even roads, heading toward new water. Their journey rarely stopped. Survivors of dirty water. Many aquatic species are sensitive to changes in their environment. Pollution, temperature shifts, or altered salt levels can quickly kill fish, shellfish, and other river creatures. The mitten crab, however, possessed an unusual advantage. It tolerated conditions that would destroy many other animals. Industrial rivers filled with runoff? The crabs could survive there. Cold northern winters? They adapted. Sudden changes in salinity near tidal estuaries? No problem. Studies showed that the species could live in freshwater, brackish water, and even moderately salty coastal environments. Its metabolism allowed it to handle dramatic temperature swings and poor water quality. This flexibility meant the crab could thrive in places most wildlife avoided. Urban canals beneath busy highways. Drainage ditches behind suburban neighborhoods. Industrial riverbanks lined with steel docks. Wherever water flowed, the mitten crab had a chance to establish itself. And once it settled in, it began to dig. The hidden engineers. Along the muddy banks of rivers, the work of the crabs was easy to miss at first. A small hole appeared near the waterline. Then another. Over weeks and months, dozens of openings dotted the shoreline. Each hole marked the entrance to a tunnel carved by a mitten crab. The tunnels could reach half a meter in length, extending deep into soft soil. Inside, the crabs found protection from predators and a safe place to rest between feeding trips. Individually, the burrows were harmless. But together, they created something far more serious. Riverbanks depend on compact soil to stay stable. Roots, clay, and sediment form a dense structure that holds the land in place against flowing water. When hundreds of crabs tunneled into that structure, they weakened it. Engineers sometimes compared the process to termites hollowing out a wooden beam. From the outside, everything looked solid. Inside, the structure was slowly being eaten away. Along parts of the Netherlands' intricate canal system, experts began noticing increased erosion where crab populations were high. Levees that protected farmland from flooding developed fragile sections riddled with burrows. In extreme cases, entire sections of riverbank collapsed. For countries that relied heavily on flood defenses, the threat was taken seriously. The crab was small, but the damage it could cause was not.